First question, it says that work out the value of 25 minus square root of 43.87 divided by 6 plus 2.1 whole square. Write down all the figures on a calculator display. So what you'll do is you'll plug in this equation in your calculator, and the value you should get is 1.76527923022291. This is the figure that will appear on your calculator. Part B says work out the value of the reciprocal of 0.625. So firstly, reciprocal of 0.625 will be 1 over 0.625, which is basically the same as 1000 over 625. Plug this in your calculator and you should get 1.6. Question 2 says write 60 as a product of its prime factors. So we're going to break down 60 into its prime factors. Let's begin with any set of prime factors. If I choose 6 and 10, we know 6 times 10 is 60. Now 6 is basically 3 times 2, whereas 10 is 2 times 5. So as you can see, 60 is equal to 3 times 2 times 2 times 5, which can be written as 2 square because we have two 2's times 3 times 5. This is 60 as a product of its prime factors. Prime factors are basically those factors which are only divisible by themselves or 1. We know 2 is only divisible by itself and 1. And same is for 3 and 5. All these three numbers are prime numbers. Question 3 says there are 48 counters in a bag. There are only red counters and blue counters in the bag. Number of red counters is to number of blue counters is 1:2. Helen has to work out how many red counters are in the bag. She says there are 24 red counters in the bag because 1 is half of 2. So 24 is half of 48. Is Helen correct? You must give a reason for your answer. So let's first try to find out how many red and blue counters are there in the bag. So for the red counters, we will do 1 over 2 plus 1 times 48. Now, why did we do 1 over 2 plus 1? Because if you look at the ratio, it's 1:2. So for 1:2, when you're trying to create a fraction for the quantities in the ratio, which in our case is red counters, in the numerator, we put the amount that corresponds to the amount that we're talking about, which is 1 for red counters. And the denominator, we write the sum of all the numbers in the ratio. That's why we did 2 plus 1. So that's going to be 1 over 3 times 48. Why times 48? Because we're trying to find the number of red counters from the counters in the bag. And the total number of counters in the bag are 48. So 48 divided by 3 is basically 16. And as you can see, it does not match with the number of red counters highlighted by Helen in the question. She's saying there's supposed to be 24 red counters, whereas in reality, there's 16 red counters, and blue will be double of 16. So 16 times 2, which is 32. And just to confirm if we're doing it correctly, you add up the number of blue counters and red counters, and that equals to 48, which is basically the total number of counters in the bag. Hence, Helen is not correct. Question 4 says n is less than 5 and greater than equal to -2. N is an integer. Write on the greatest possible value of n. So if we list down the values of n based on this inequality, it's going to be -2 because -2 is included. Then we have -1, 0, then 1, 2, 3, and 4. All of these numbers are included in this inequality. And the reason why we're writing whole numbers is because n is an integer. Now, what is the greatest possible value of n? Over here, greatest possible value is 4. Why? Because -2, -1, 0, 1, 2, 3 are all smaller than 4. So your greatest possible value will be 4. Then it says on the number line below, show the inequality where m is greater than or equal to -4 but less than 1. So let's highlight -4 and +1. So at -4, we'll draw a shaded circle, and at 1 we'll draw an unshaded circle. Since the inequality is converging, so we connect the two circles, and this shows that m is greater than or equal to -4. The shaded circle shows that the value is included, which is -4 in this case, and the unshaded circle shows that the value is not included, which is 1 in this case. So from -4 to 1, this will be your inequality on the number line. Then say solve 2/5 of g minus 4 less than 6. So let's first take the 4 to the other side. So we'll have 6 plus 4 over here. That's going to be 10. Now cross multiply to get rid of the 5. So 2g equals to 10 times 5, which is 50. Now we divide both sides by 2 to make g the subject. 50 over 2 is going to be 25. So g is less than 25. That is your answer. Question 5 says here's a triangle and a rectangle. All measurements are in centimeters. The area of the triangle is 10 centimeters square greater than the area of the rectangle. Work out the value of x. So area of a triangle has the formula of 1 over 2 times base times height. This is our height and this is our base. So we'll do 1 over 2 times 8 times 6x, which is basically going to be 24x. Now for the area of the rectangle, the formula is length times width. So that's going to be 5 times 4x minus 1, which is basically 5 times 4x is 20x, and 5 times -1 is -5. So it says that the area of the triangle is 10 centimeters square greater than the area of the rectangle, which means 24x is 10 centimeters square greater than, which means add to 20x minus 5, which is the area of the rectangle. Now, if we collect the like terms on the right-hand side, 10 minus 5 is 5, plus 20x remains as it is. Now, I'm going to take 20x on the left-hand side, that the like terms are collected on one side. So 24x minus 20x is 4x. So x is going to be 5 over 4. That is your answer. Question 6 says, last year, family recycled 800 kgs of household waste. 57% of this waste was paper and glass. Weight of paper recycled is to weight of glass recycled is 12:1. Calculate the weight of glass the family recycled. So first, let's find out what's the weight of paper and glass. Weight of paper and glass. So that's going to be 57% of the total waste, which is 800 kgs. So that's going to be 57 over 100 times 800, which basically equals to 456 kilograms. Now we have to find the weight of glass. So weight of glass is going to be 7 over 12 plus 7, times the total weight of paper and glass, which is 456. This is similar to the red counter and blue counter question that we did, in which Helen assumed that, it's going to be half. And like the way we calculated, like we made the ratio and times it by the total amount. This is exactly what we're doing. 7 over 12 plus 7 is 7 over 19 times 456. And that is equal to 168 kgs. That is your weight of glass. Question 7 says a number D is rounded to one decimal place. The result is 12.7. Complete the error interval for D. The error interval for this is going to be 12.65 and 12.75. Why? Because if we look at the inequality, it's the smaller value is less than equal to D and the bigger value is the smaller value is greater than equal to D and this bigger value is less than D. So 12.65 rounded would be 12.7, but it has to be a number less than 12.75. So 12.74 rounded would be also 12.7. Hence, your interval for D is 12.65 to 12.75. Christine buys a house with a value of £150,000. The value of Tamsin's house increases by 4% each year. Rachel buys a house with a value of £160,000. The value of her house increases by 1.5% each year. At the end of 2 years, whose house has the greater value? So to show that, let's find their values first. For Tamsin, it's going to be your initial value times 1 plus the percentage increase, whole power t. Now, t is your number of years and percentage is your increase or decrease in value. In this case, since we are showing an increase, that's why we're adding 1 to the percentage. Because obviously the house has its initial value like as well. So to that initial value, there has been an increase in the value by 4% for Tamsin. So we add the percentage to 1 to show how the initial value is increased. So it's going to be 150,000 times 1 plus 4 over 100 whole power 2 because it's for 2 years, which is going to be 150,000 times 1.04 whole square, which basically gives us 162,240 pounds. Now, if we draw the same calculation for Rachel, formula would be the same. So it's going to be 160,000 times 1 plus 1.5 over 100. And the number of years are same, 2. So that's going to be 160,000 times 1.015 whole square, which is going to give us 164,836 pounds. So now if we look at their final values after 2 years, we can see that Rachel has greater value as compared to Tamsin's house. So answer is Rachel. Question 9 says the cumulative frequency table gives information about the ages of 80 people working for a company. So we have the intervals for the age in one column and the corresponding cumulative frequency in the other column. On the grid opposite, draw a cumulative frequency graph for this information, and then use your graph to find an estimate for the median age. So let's write down the values first. 30, 20. Remember, we always take the maximum value when we're plotting the cumulative frequency graph. So 40 and 48 50 and 64, 60 and 75, and 70 and 80. So now let's scroll down to plot this. So now if we plot this over here, 30 and 20, that's over here. 40 and 48, 50 and 64, 60 and 75, and 70 and 80. So now let's connect them. Okay, this is a cumulative frequency graph, and they're asking us to find the median. So for the median, we divide 80 by 2, and that is 40. So we have to mark the 40th value on the y-axis, and then see what we get on the x-axis. So what I'm getting is 37. So median is 37 years. Question 10 is a dice is thrown 60 times. The table shows information about the number that the dice lands on each time. Ketan throws the dice twice. Work out an estimate for the probability that the dice will land on 6 both times. So for the dice to land on 6 both times, we know that the frequency is 15 for that. So we will do 15 over 60 because the dice is thrown 60 times. Then times again 15 over 60. Now we know 15 is 5 times 3. So if we divide this by 3, that's 5 over here, and that's 20. And that's 1, and that's 4. So this will also be 1 over 4. So 1 over 4 times 1 over 4 is 1 over 16. That is your probability. Sally is going to throw the same dice n times and record the number it lands on each time. She will use the results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? So since she wants a more reliable estimate, that means her n is supposed to be greater than 60. Because she's already thrown the dice 60 times and she knows the values for that. And she knows like the frequency at which the numbers are pairing. So to have a more reliable estimate, she has to make sure that she is throwing the dice more than 60 times. The greater the number of times she is throwing the dice, the more reliable her results will be. Question 11 says use algebra to solve the simultaneous equation. So we have two equations, 2x plus 6y equals to 5 and 3x minus 4y equals to negative 12. I'm going to use elimination method for this. So for elimination method, what we do is we try to eliminate a variable. So in this case, I choose variable x to eliminate. You can also eliminate variable y, like there's no restriction. I am picking x. So in order for me to eliminate variable x, I need to make sure that the coefficient of x are equal in both the equations. As you can see in the first equation, x has the coefficient of 2. And the second equation, x has the coefficient of 3. So to make the coefficients equal, I'm going to multiply the first equation by 3 and the second equation by 2. So now the equations are 6x plus 18y equals to 15. And the other one is 6x minus 8y equals to negative 24. As you can see, we have the same coefficients of variable x. So now it's going to be easier for us to eliminate it. Next step is to check what signs the coefficients have. So as you can see in the first equation, 6x is positive, and the second equation, 6x is also positive. So for us to be able to eliminate x, we need to subtract the equations. Why subtract the equations? Because both 6x have a positive sign. So if we add the equations up, it would be 6x plus 6x, it would give us 12x. We won't be eliminating x, we would just be increasing it in value. So for us to eliminate x, we need to subtract both the equations because only 6x minus 6x will eliminate x. So we do 6x plus 18y equals to 15 and 6x minus 8y equals to negative 24. And now we subtract the two equations. 6x minus 6x plus 18y minus negative 8y equals to 15 minus negative 24. 6x minus 6x is 0. So as you can see, x got eliminated. And 18y minus negative 8y is 18y plus 8y because minus times minus is positive. Similarly, it's going to 15 plus 24 over here. So that's going to be 26y equals to 39 and y equals to 39 over 26, which is basically 3 over 2 because both 39 and 26 come in the 13 times table. Now that we have the value of y, we will substitute this into either of the equations to get the value of x. You can use the original equations, you can use new equations, either way your answer would be the same. I'm going to suggest using the original equations because like they're smaller in value, it's going to be easier to calculate it. So if I use the first one, 2x plus 6y equals to 5, I will substitute y as 3 over 2. So that's going to give us 2x plus 9 because 6 times 3 by 2 is 9. 2x equals to 5 minus 9, which is negative 4. So x is going to be negative 4 over 2, which is negative 2. So x is negative 2 when y is 3 by 2 for this set of simultaneous equation. Y can also be written as 1.5 if you want to, or you could leave it as 3 by 2 as well. Question 12 says the points A, B, C, and D lie on a circle, center O. ABC is a rectangle. AB is given as 8 centimeters, BC is 10 centimeters. We have to work out the circumference of the circle, giving our answer correct with 3 significant figures. So I'm going to first connect A with C. Why? Because AC is the diameter of the circle. It's passing through the center and touching the circumference on both ends. And OC is equal to AO, and both represent the radius. So since a rectangle has 90-degree angles as its all four angles, we can use Pythagoras to find the value of AC. So AC square is going to equal to AB square plus BC square. AC is our hypotenuse, AB and OB are opposite and adjacent. So AC square is going to equal to 8 square plus 10 square, which is 64 plus 100. That's going to be 164. Now we take square root on both sides to get rid of the square on AC. So AC is going to be equal to 6.403 centimeters. .806 centimeters. Now to find the radius, which is OC, we divide 12.806 by 2, which gives us 6.403 centimeters. Now, circumference has the formula of 2 pi r. So we will do 2 pi times 6.403, and that's going to give us 40.2 centimeters. This is your circumference correct to 3 significant figures. Question 13 says ABC is a triangle. Calculate the sides of angle BAC. Give your answer correct to 1 decimal place. We have to find this angle. So before we find this angle, I'm going to first find angle C. Angle C is going to be found using sine rule. The reason why I'm using sine rule is because we have one complete set of length and angle with us. And for the other measurements, we have the length, but we need to find the corresponding angle, which means we can use the sine rule where it's going to be AC over sine of angle B equals to AB over sine of angle C. 18 over sine 70 equals to 15 over sine of angle C. So we do 18 times sine of angle C equals to 15 times sine 70. Sine of angle C equals to 15 sine 70 divided by 18. That's going to give us 0.783077. Now we take sine inverse of this. And that will give you 51.54 degrees. So now that we have this angle, we can easily find the third angle by using the formula of sum of angles in a triangle equal to 180. So we will put 180 equal to the sum of 70, 51.54, and angle A. So 180 minus 70 minus 51.54 equals to angle A, which is basically 58.5 degrees is your angle A. Question 14 says, show that x squared minus x minus 6 divided by 2x squared minus 5x minus 3 can be written in the form of ax plus b over cx plus d, where a, b, c, and d are integers. So what we're going to do is we're going to factorize the numerator and denominator. So let's factorize those separately first, and then we can just write them together. So we have x squared minus x minus 6. First, we multiply the coefficient of x squared with the constant, which is going to be 6. Then we find factors of that value. So that's 6 times 1 and 3 times 2. Now we pick that set of factors, which when added or subtracted gives us the middle term, which is negative 1x. So we know that 6 plus 1 is 7 and 6 minus 1 is 5. So we can't use that. But we know 3 minus 2 is 1. So if we use x squared minus 3x plus 2x minus 6 instead of x squared minus x minus 6, we get x bracket x minus 3 plus 2 bracket x minus 3. What we did over here is we split the equation after we replaced negative x with negative 3x plus 2x. We split it into two groups. When you split it into two groups, we factorize them separately. So when you factorize x squared minus 3x, we get x times x minus 3. And when you factorize 2x minus 6, we get 2 times x minus 3. So now we can see that between x and positive 2, we have x minus 3 common. So I'm going to take x minus 3 common, and the other bracket we'll have x plus 2. So this is the fully factorized version for x squared minus x minus 6. Now we're going to factorize the other one, which is 2x squared minus 5x minus 3. Same steps. We first multiply the quotient of x squared with the constant. So that's going to be 6 again, which means the factors are also going to be the same. Now this time I'll choose 6 and 1. Why 6 and 1? Because if we replace negative x with 6, we know 6 minus 1 is 5. But we also know 3 plus 2 is 5 as well. In this case, we know that 6 minus 1 is 5 and 3 plus 2 is also 5. Both are giving us the middle value, which is 5x over here. But we can only choose one set of factor. And I'm going to show you how you know which one you're supposed to choose. So if I pick the first one, which is 6, which is 3 and 2. If I pick 3 and 2 first, we will have 2x squared minus 3x minus 2x minus 3. I replaced 5x with negative 3x minus 2x. Now factor by grouping again. Between 2x squared and 3x, we have x common. So 2x minus 3 over here. And between negative 2x and 3, we have negative 1 common. So 2x plus 3 over here. As you can see, we cannot further factorize this because the brackets don't have the same sign. It's 2x minus 3 in the first bracket and 2x plus 3 in the second bracket. We can't further factorize it. This equation stops over here, which means 3 and 2 are not the best options. Now, if you pick the other one, so it's going to be 2x squared minus 6x plus x minus 3. Again, factor by grouping. Between the first two terms, we have 2x common, so x minus 3. And between the last two terms, we have positive 1 common. So as we can see, we're getting x minus 3 again, which means this was the correct set of factors. We take x minus 3 common, and we get 2x plus 1. So now that we've fully factorized both the equations, we can rewrite them as x minus 3 times x plus 2 divided by x minus 3 times 2x plus 1. As you can see, we have an x minus 2 in the numerator and denominator. We cancel it out, and we're left with x plus 2 over 2x plus 1. That is our answer. In question 15, they're asking us to find the nth term for this quadratic sequence. So what we're going to do is first, we're going to find the first difference between the sequence. So we have 3, 9, 17, and 27. So between 3 and 9, there's a difference of positive 6. Between 9 and 17, there's a difference of positive 8. And between 17 and 27, there's a difference of positive 10. This is our first difference. Since the first difference is uncommon, we find the second difference. Between 6 and 8, there's a difference of positive 2. And between 8 and 10, there's a difference of positive 2 again. So this is our second difference. Since the second difference is common, we can already see that it is a quadratic sequence, which was given in the question as well. So now to find the quadratic sequence, so now to find the nth term of the quadratic sequence, we need to remember that the quadratic equation comes in the format of an squared plus bn plus c. So our nth term is also going to be in the same format. So you first begin with finding the value of a. A is going to be your second difference divided by 2. So that's going to be 2 over 2, which is 1. So a value is 1. So it's going to be n squared plus bn plus c. This is what we have so far. Now to find the value of b, we create another equation. So first equation was a equals to 2 over 2, which is equal to 1. So that's done. Next equation is 3a plus b, which basically equals to your second term minus the first term. This equation will be used to find the value of b. We already know the value of a, which is 1. So 3 times 1 plus b equals to second term, which is 9, and first term is 3. So 3 plus b equals to 6, and b equals to 6 minus 3, which is 3. So we know that b is n squared. So now we know that the nth term is n squared plus 3n plus c. Now to find the value of c, the next equation that you will use is a plus b plus c equals to the first term. This equation is used to find the value of c. So a is 1, b is 3, and c is what we have to find. And the first term is 3 as well over here. So that's going to be 4 plus c equals to 3. And c is 3 minus 4, which is -1. Which means the nth term is going to be n squared plus 3n minus 1. That is your answer for this quadratic sequence. Question 16 says the histogram gives information about the number of hours some students used their phones last week. The histogram is incomplete. 28 students used their phones for between 30 and 40 hours. 24 students used their phones for between 40 and 60 hours. Use this information to complete the histogram. So what we will do is, we will first find the frequency density for these two intervals. So for 30 to 40, they've given us the frequency, which is 28. So we will use this value to find the corresponding frequency density and then create a scale based on that. So frequency density has the formula of frequency over class width. Frequency is 28, and class width is the difference between 40 and 30, which is 10. So that's 2.8. So which means the frequency density at this point is 2.8. So if that is 2.8, which means this is 2, this is 3, and this is 1. Two big boxes add up to 1 unit. That is the scale that they've taken. So for 24 students, the frequency density is going to be 24 over 20, which will equal to 1.2. So the remaining histogram is this thing. Frequency density is 1.2, and the class width is from 40 to 60. It says no student used their phone for more than 60 hours. Work out the total number of students now. So we already know that for 30 to 40, there are 28 students, and from 40 to 60, there are 24 students. For the scale, we previously said that two big boxes equal to 1 unit. So this is 1, 2, 3, and 4. So for the frequency density from 0 to 20, that's 1.1, 2, 3, 4, 5, 1.6. And this is 3.6. So what we will do is we will find the corresponding frequency for this. So for the first one, 1.6 equals to f over the class width, which is 20. So 1.6 times 20 equals to f, which is basically 32. And then for the other one, 3.6 equals to f over 10. 3.6 times 10 equals to f, and that is 36. That is the frequency from 20 to 30. So now total students are going to be the sum of 32 plus 36 plus 28 and plus 24, which adds up to 120. That is the total number of students. Question 17a says, show that the equation x to the power of 4 minus x squared minus 5 equals to 0 can be written in the form of x equals to 4th root of x squared plus 5. So what we're going to do is we're going to make x to the power of 4 the subject first and take everything else to the right-hand side. So that's going to be x squared plus 5. Now I'm going to take the 4th root on both sides. So 4th root of x to the power 4 is x itself, and this is your remaining equation, which is what we were supposed to show in the question. Then it says starting with x0 equals to 1.5, use the iteration formula xn plus 1 equals to 4th root of xn squared plus 5 3 times to find an estimate for the solution of this equation. So for n equals to 1, we start with n equals to 0. So that's going to be x0 plus 1 equals to x1, which equals to 4th root of x0 whole square plus 5, which is 1.5 whole square plus 5, and that equals to 1.640909. Then for n equals to 1, it's going to be x1 plus 1, which is x2 equals to the 4th root of x1 whole square plus 5. That's going to be 1.640909 square plus 5, and that equals to 1.665398. Then for n equals to 2, it's going to be x2 plus 1 equals to x3, which is the 4th root of x2 square plus 5. That's going to be 1.665398 squared plus 5, which will give you 1.66976. That is your estimate for the solution of the equation. Question 18 says 2a is to 5c equals to 6 is to 25 and 4b is to 7c equals to 20 is to 21. Show that a plus b is to b plus c equals to 17 is to 20. So let's rewrite these ratios as a fraction. 2a over 5c is the same as 6 over 25. So let's make a and c, let's isolate a and c on the left-hand side. So it's going to be a over c equals to 6 times 5 over 25 times 2. I just cross multiplied 2 and 5 to the numbers on the right-hand side to isolate a and c. So that's going to be 35. That's going to be 30 over 50 for a over c, which can be simplified to 3 over 5. Now let's do the same thing for 4b is to 7c. So 4b over 7c equals to 20 over 21. b over c equals to 20 times 7 over 21 times 4, which is going to give us 140, 84. And that simplifies to 5 over 3. So now we know that a is to c is 3 is to 5. and B is to C is 5 is to 3. Since C is being used in both the ratios, we need to make those quantities equal. So to make the quantity of C equal, we need to multiply the C in A is to C by 3, and the C into B is to C by 5. Since the C's are being multiplied, we have to do the same to A and B as well. So A gets multiplied by 3 and B gets multiplied by 5. So that's going to give us 9 is to 15 and 25 is to 15. Now A is to B is to C can be written together as 9 is to 25 is to 15. So we were supposed to find A plus B ratio B plus C. So A plus B, 9 plus 25. B plus C is 25 plus 15. So that's 34 ratio 40. 34 and 40 both are divisible by 2. 34 divided by 2 is 17 and 40 divided by 2 is 20, which is the same as what the question was asking us to show. So this is your answer. Question 19 says ABC is a right angle triangle. AB is 9.3, AC is 12.6. Calculate the lower bound for the size of the angle marked X. So firstly, we need to find out which trig ratio we will use. Since the angle is situated on BC, that means 9.3 is our opposite and the diagonal is always the hypotenuse. So we have the opposite, we have the hypotenuse, and we have to find the angle, which means we will use sine of X equals to AB over AC. Now, since they ask us to find the lower bound of the angle, so when we're finding the lower bound in like division questions, what we do is our numerator will always be the lower bound and the denominator will be upper bound. Why? Because we need the lowest possible value, which the lower bound represents. So lowest possible value can only be found if we divide the lower bound by the upper bound. If we were dividing the upper bound by the lower bound, then we would get the highest possible value, which is not what we're looking for. So once again, to find the lowest possible value, which is the lower bound, in division, you will divide the lower bound by the upper bound. So what we will do next is we find the upper bound and lower bound for the given values. So for AB, what we will do first is let's convert the millimeters into centimeters because the lengths are given in centimeters. So we know 1 centimeter is 10 millimeter, which means 1 millimeter will be 1 over 10 centimeter, which is 0.1 centimeter. So when we're trying to find the upper bounds and lower bounds, we first divide the degree of accuracy by 2. So in this case, the degree of accuracy is 0.1. And when we divide that by 2, we get 0.05 centimeters. So lower bound of AB will be 9.3 minus 0.05. In lower bound, we subtract. In upper bound, we add. So 9.3 minus 0.05 is 9.25 cm. And for AC, degree of accuracy is 0.1 as well because nearest millimeters divided by 2, which is 0.05. So your upper bound will be 12.6 plus 0.05 now. Is going to be 12.65 centimeters. So sine X would be 9.25 divided by 12.65. And we take sine inverse of that. And that will give us 46.99 degrees. That is your lower bound for the angle x for this right angle triangle. If there's still any confusion, I will attach the link for like a separate video for finding the upper bound and lower bound in like division. And if you're still struggling with it, let me know in the comments below and help you out. Question 20 says ORT is a triangle. OT is given as A. RT is given as B. M is a point on OR such that OM is to MR is 2:3. Express MT in terms of A and B. So let's first find OR. OR is going to be OT plus TR because I'm taking this root for OR. So OT is A, TR will be negative B. Why negative B? Because RT was positive B. And since we're changing the direction of the vector, we're making it from T to R now. So when you change the direction, the sign of the vector changes. So instead of being positive B, it's now negative B. So A minus B is OR. Now OM is to MR is 2:3. OM is going to be 2 over 2 plus 3 times OR, which is 2/5 of OR. And MR is going to be 3 over 2 plus 3 times OR, which is 3/5 of OR. So if we find the value of OM, that's going to be 2/5 of A minus B. So for MT, I'm thinking of going from M to O, then from O to T. And that will give us MT. So if I do that, MT would be MO plus OT. MO is going to be the opposite of 2 over 5 times A minus B. So that's minus 2 over 5 times A minus B plus OT is A. So that's going to be negative 2A plus 2B plus 5A over 5. I just combine it as a single fraction. So that's basically 2B plus 3A over 5. That is MT in terms of A and B. Question 21 says, here's the graph of y equals to fx. On the grid, draw the graph of y to fx minus 4. So I'm going to show it over here so that you can see how the original is changing. So fx minus 4. What's going to happen is that all of your y values are going to be decreased by 4, which means this was 1 over here. So we know 1 minus 4 is negative 3. So now this point is going to come over here. This point is going to come over here. From 0, it's going to go at negative 4 and negative 4. There is a vertical translation downwards by 4 units. So as you can see, the shape went 4 units down. Only the y coordinate is changing, the x coordinate remains as it is. If it was plus 4, then your shape would go 4 units up. Next, it's saying, draw the graph of y equals to f of negative x. So for f of negative x, only your x coordinates are going to change now. So what's going to happen is that you're going to multiply negative with all of your x coordinates. So negative 3 becomes positive 3. 0 remains 0 because negative or positive 0, it's the same thing. Negative 2 becomes positive 2 and negative 1 becomes positive 1. As you can see, the y coordinates are exactly the same this time, but what's changed is your x coordinates. Whatever was negative became positive now. Or if whatever was positive, that would be negative. But in this case, since all of the coordinates, all of the x coordinates of the original shape are negative, so in the transformation, they're positive. Which, in other words, you can say it's just a reflection in the y-axis. Question 22 says there are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. Rita takes at random one pen from the box. Then she records the color of the pen and then replaces it in the box. Rita does this n times where n is greater than equal to 2. Write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. So let's first draw the tree diagram for this. So we have blue pens and we have red pens. Blue, red, blue, red. She's picking them greater than 2 times, greater than equal to 2 times. So it's starting from 2 times and then she's just repeating the process. So we know that blue pens are 4 times the red pens, which means if red are x, blue are going to be 4x. So the probability of blue over here, we can say that it's going to be 4x over 5x. And red is going to be x over 5x because x plus 4x is 5x. So that's the denominator. And numerator over here is 4x and x for each. So that means over here, since they're being replaced, so that's going to be 4x over 5x again. X over 5x again. Same over here. Same over here. Now this is just the first time. Since she's doing it n times and n is greater than or equal to 2, so it's just going to keep on going. So if it's going to keep on going, then the probability of blue will be 1 minus 1 over 5 to the power of n. Now, the reason why it's 1 minus 1 over 5 to the power of n is because if we just look at the probability of blue without the n thing, blue would be 1 minus 1 over 5, right? Because it's 4 over 5. And if we take out the probability of red from the entire event, we're left with the probability of blue. That's why we write 1 over 1 over 5. That's why we write 1 minus 1 over 5. Now, since she's taking the pens out n times, so we make 1, so we give 1 over 5 the power of n, because n number of times she will be drawing the pen. We don't know what the value of n is, because they've just given us a range of n greater than or equal to 2. So it can be any value that's greater than or equal to 2. Similarly, for red, it's going to be 1 minus 4 over 5 to the power of n. Because the probability of red is 1 minus 4 over 5. And to 4 over 5, we again give the power of n because we don't know how many times she's doing this. So that is going to be 1 minus 4 over 5 to the power of n, then minus 1 over 5 to the power of n. Because if we look at the question again, it says, for the probability that Rita gets a blue pen at least once and a red pen at least once. So we subtract both the probabilities from 1 because we don't know how many times she's getting which one. So to sum it up, it's going to be 1 minus 4 over 5 to the power of n minus 1 over 5 to the power of n. Question 23 says, here are 3 similar triangles, ABG, ACF, and ADE. So let's draw them first. This is the first triangle. This is the second one. And this is the third one. A, B, G, A, C, F, and A, E, A, D, E. A, B, C, D, and A, G, F, E are straight lines. AB is to BC is to CD is 1 is to 2 is to 3. Show that area of ABG is to area of BCFG is to area of CDEF is 1 is to 8 is to 27. So they've given us the ratio of 1 is to 2 is to 3 for AB, BC, CD. So AB is 1, BC is 2, and CD is 3, which means I can assume that AD will be 1 plus 2 plus 3, which is 6. And AC is going to be 1 plus 2, which is 3. So 1, 3, and 6. So if I use these to find the area, we know that these three triangles are similar. And in similar shapes, your square of the lengths will give us the area. So if I square these three lengths, I get 1 is to 9 is to 36. This is for area of ABG. This is area of ACF. And this is area of ADE. Okay. So they want to show that area of ABG is to BCFG is to area of CDEF is what is to 8 is to 27. So now going back to the shape, let me just remove this. One, two, three. Okay. So ABG area is what we have, which is 1. Area of BCFG, this is BCFG. So BCFG is going to be area of AFC minus AGB, which is going to be 9 minus 1, and that's 8. And then area of CDEF, which is going to be this one. We will do area of AED, which is 36, minus the area of AFC, which is 9. That's going to give us 27. So as you can see, the ratio is 1 is to 8 is to 27, which is same as what's given in the question. And that is your answer. Question 24 says the diagram shows 8 identical regular octagons joined to enclose a shaded shape. Each octagon has sides of length A. Find in terms of an expression for the area of the shaded shape. Give me your answer in the form of P times 2 plus root 2A squared, where P is an integer, and you must show all your working. So we know that the octagon has length A, and it's a regular octagon, so all lengths are equal. So this is A, this is A. Let's write all the A's. A. Now, if I join these 2 points, we know that the exterior angle of a polygon has the formula of 360 over n. To find the exterior angle of a regular octagon, we divide 360 by 8, and that equals to 45. Which means this is 45 and this is also 45. So together it adds up to a 90. So if I draw this triangle over here separately, it's basically a right angle triangle with the length A over here, and we don't know what this length is. So we're going to find this length over here using Pythagoras. X square equals to A square plus A square. X square equals to 2A square. And x is going to be square root of 2A square, which is basically A root 2. Now that we find the area, now that we find the length of this space, which is A root 2, we already know that this is A, this is A. So since all of these are identical, this is also going to be A root 2. This is also going to be A root 2 and A root 2. So now you can see that we know the dimensions of all of the parts of this square. So we know all of the parts for the dimensions of this quadrilateral. So if we add up the length is going to be A plus A root 2, which is 2A plus A root 2. And for the width, it's exactly the same, so it's a square, 2A plus A root 2. So now they're asking us to find the area of the shaded part. So we can find the area of the square by doing 2A plus A root 2 times 2A plus A root 2, which is going to be 4A square plus 2 root 2A square plus 2 root 2A square plus A square times root 2 square. So now if I move this part over here, that's going to give us 4A square plus 4 root 2A square plus 2A square, which is 6A square plus 4 root 2A square. This is the area of the square. Now for area of the triangle, that's 1 over 2 times A, which is A square over 2. And since there are 4 triangles, that's going to be 4 times A square over 2. And that's 2A square. So now total area is going to be 2A square plus 6A square plus 4 root 2A square. That's going to be 8A square plus 4 root 2A square. We will take 4 and A square common, and that's going to leave us 2 plus root 2 in the bracket. So P value is 4, A square is as it is, and 2 plus root 2 is as it is. So that's your answer.